Welcome to a episode of Electricity with Grandpa. This episode I decided to do after I had already made like 8 episodes of this series because I realized that although I was extremely familiar with CAD, having worked with Autodesk, AutoCAD, and other CAD packages for years, I started with AutoCAD at version 2. And then I kind of dropped out at release 14, and that would have been about 2000, I think. So I don't do much electrical CAD anymore, and when I do, I use SkyCAD, SKYCAD, because it's free. And SkyCAD is much simpler to use than AutoCAD, simply because AutoCAD tries to cover all the bases. So when you go into AutoCAD, you have to pick a door to go through. With SkyCAD, it's just electrical, and it's free, and it's a good start. Now, once you get a job where you're going to actually work with CAD and do circuit designs, panel designs, etc., then by all means, AutoCAD electrical. So right now we're going to talk about TinkerCAD, and I realized when I was demonstrating it in like episode 2 and the other episodes, I was doing things that you really didn't see how I was doing it. So what I'm going to do is I'm going to create a little video here. I'm going to open up TinkerCAD. I'm going to show you how to start. And I'm going to create a few things and discuss a few of the parts and the wiring and how you move about, just to kind of grease your skids to get into this. So let's get started and have a look at TinkerCAD. When you open TinkerCAD, you're not going to see all of this. It's hard to make a clean start for me because I have dabbled with this off and on over the years. If you scroll down here, you can see 5 years ago. So 5 years ago, I did something with servos and Arduino. I did a variety of things. And it's only recently, 2 years ago, that I created a little circuit using a relay, a 5-volt DC relay right there. And I did something a little bit more in the direction that we're going in this series. And then 13 days ago, I did this circuit, flashlight with ammeters and voltmeters. And so you see I progressed. And then 4 minutes ago, I was actually working on this one. So when you open up yours for the first time, you're not going to see anything, but you want to pick circuits, okay? Not 3D, not code blocks, but you want to pick circuits. And then you want new circuit. And it comes up with a blank workspace here. Now, there's a button over here that resizes this so all of your project fits within the screen. Well, we've got no project. So maybe later on I'll use that button to show you how it zooms out to see everything you've got scattered around. But for all basically purposes, this space right here, it's not infinite, but it's really big. So you can create things and you can just keep moving stuff around, moving it out of your view, moving it down, moving to the side. And so you can continue to add things. And then if you get too much in that space and you want to see everything, then you click on this button over here, which is resizes to fit, zoom to fit. It fits everything. And then you can zoom in on the one that you want to work on. So let's start with something really simple. First of all, these are the components over here. And this component list, it's the basics. You see this arrow right here? Hide component panel. That gives you more workspace. And then show component panel. Under components, you have basic, all, and then you have starters. Starters are circuits already assembled, and you can pick one and start modifying it or analyzing it. We're not going to do that yet. So I'll pick all, and then scroll down, and you can see that there are quite a few components. We don't want all those components visible. You want to stick to basic, okay? Because we're going to use initially components that you see right here. The only one I don't see right there that we're going to use is the light bulb and the meter. So I don't see the light bulb. Maybe it's there and I've just not seen it. But if I type in here under search, LIGHT, I just realized the microphone wasn't aimed at me, so it'll probably get louder now. If I type in light, it comes up with 3 items here. An LED, a RGB LED, red, green, blue LED. With this type of LED, it has a common, and then it has a red, a green, and a blue lead. And so there are 3 LEDs inside of this little plastic potted device here. It's the lens. The face of this is called the lens. And you can turn on the red, the green, the blue separate, or at different levels to create millions of colors. Then you got a photoresistor that's really not a light, but it's sensitive to light. So it is a resistor that has a light resistance coefficient. As the light increases, the resistance goes up or down, and vice versa. I'm not seeing the bulb here, so I'm going to type in bulb. There it is, light bulb. So that's a basic component. So I can bring one over here and drop it. Okay, now because I'm in the default view, meaning fit to the whole screen, it made everything as large as possible. Later on, when I zoom down, and to do that, we'll just pick on this light bulb. Okay, if I take the scroll button on my mouse and go forward, it gets bigger. If I go in reverse towards me, in other words, I'm rotating the top of the scroll wheel towards me, it gets smaller. Go forward, it gets bigger. This is something that you have to practice with. If you want to move it, then you select it, hold the mouse button down, and then drag it to wherever you want it. Okay? If you want to zoom in, put your mouse where you want to zoom in. See? Zoom out. You don't have to put it right on the device. Let's say you want to zoom in and move it towards the middle. Scroll the scroll wheel forward off to the side. Let's say you want to make it go down. Scroll back towards you with the mouse right below it. If you go right above it, it scrolls it down in a different position. So this is something you have to practice with. So when you first start playing with TinkerCAD, bring a component out here and start working with the scroll. Hold down the mouse button to move it around. There's only one thing on there, okay? So it's a question whether or not you have to have your mouse right on it. But it's basically moving the workspace around, okay? If I do this, it moves it within the workspace. If I do it here, it moves the whole workspace. But because we only have one component, I can fix that. Bring another one out here, okay? So now I'm going to pick that one. See, it moves it around in the workspace. If I click here, it moves the whole workspace. Okay, you with me? If I put the mouse here, right between the two, and roll the scroll button forward, it zooms in with where the mouse is at is the center of the zoom. Or leave it there and move out. If I go over here and zoom in, see, it moves it off to one side. Go over here, zoom in, moves it off to the other side. Here, moves it down, moves it up. Okay, so play with this. So I'll click on that and delete that bulb. Now there is nothing to the bulb. You could put a name on it. I'm not going to bother. We'll just call it 1. Let's leave it. Notice under my search, I still have light B. There are other components. So I'm going to backspace out of that. When I do, it goes back to the default display. Okay? So I've got a light bulb. Now I'm going to do something just for grins. I don't know how many watts or what the voltage rating is on this light bulb. So just for grins, I'm going to drag in a 9-volt battery. And to make this look more tidy, I'll bring that up. And now I'm going to hit R. So I'm not holding the mouse button down, I'm just hitting R. If I hold Shift R, it rotates the other way. R shifts it clockwise. Okay, now just for grins, because these two seem to line up, I'm going to see if I can get away with just connecting them like that. Okay, looks like it's connected. How do I know it's connected? Well, I don't know. Let me try this. I'm going to start simulation. Oh, the light bulb goes on. So we're connected. And notice up here that we have a simulator time. It's telling you how long the simulator's been running. Stop simulation, start simulation. Okay, so I know that this light bulb will handle 9 volts. And I can't help myself. I'm going to disconnect it. I'm going to put the mouse button right here. I'm going to scroll backwards to make it smaller. Now I want another battery. I could drag one from over here, click on it and put it over here. Or what I tend to do, if it's already on the screen, I select it and I hit Control C. And if I hit Control V without moving the mouse, it kind of puts it right where the mouse is at. Okay, so I'm going to drop this battery right there. Now I'm going to take and connect a wire from this battery to the next battery. So when you see that little red square pop up, hold the mouse button down and drag it over until you see the red square, and then click, release and click. Okay, click, 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 release, and click. Now you need to practice this stuff. This is not a practical circuit. We're just playing with this thing. Start simulation. Oh my, look at that. It won't handle 18 volts. Okay, so that bulb must have a voltage rating of 9 volts, maybe 12. Now I know how we could actually find out. But when you see any of the parts over here with that little red splash, that means there was a bang and smoke. Okay, so I'm going to disconnect this wire. I'm just going to select it, click off of it. I'm just doing this so you can see the whole thing, and hit delete. And now I'm going to delete this battery. And instead, I'm going to bring over one of these. So this gives me 1.5 volts. Okay? Now what I don't like about this is that the plus and the minus is on the opposite side. See? So I can't just bring a wire from here to here because that's minus to minus. But I think I can right-click on here and say I want, oh, this is even better. I'm going to delete the 9-volt battery, so I click on it and hit delete. Now I'm going to click here. I want to say I want 4 batteries. Maybe that's as many as I can get. Oh, it is. It's not going to let me have any more than 6 volts. Well, that's too bad. But I can do this. I can right-click on that, or click on it and say Control C, Control V, just like you would in a word processor. Now I've got 12 volts. Remember, 1.5 plus 1.5 plus 1.5 plus 1.5 is 6. And notice that the batteries are put in series, so the total voltage, if this is the way I think it is configured in the software, it should be 6 volts. Now let's say I wasn't sure. Well, I can scroll down here, bring over a meter, hook a meter right to it, make it voltage, hit simulation, and I've got 6 volts. Okay, you see what I did? I just clicked on the multimeter, clicked on where I wanted it on the screen. Now I'm going to drag it off, stop simulation. You can't do a whole lot while you're running the simulation. You have to stop it to make changes. So now I'm going to hook up to the bulb, from here over to here, from here over to here. I'm not being real neat about how I'm drawing these wires. I'm going to start simulation. Ooh, it can handle 12 volts. How do I know it's 12 volts? I can take the meter lead from here. Oh, there's two ways I could do it. I could show it across the bank of batteries, these 8 batteries. Because basically, stop simulation. But I think I'm going to bring it over here. And then I'm going to drag the red wire over to that terminal on the light and bring the black wire over to this terminal on the light bulb. So it's actually across the light bulb, even though it's the same as being across the battery. If I select this wire and hit 1, it turns it black. If I hit this wire and hit 2 on my keyboard, it turns it red. Now that looks more like meter leads. And by the way, if you don't like the way I've drawn this, you can tidy it up. See what I mean? You can drag it around until you see those blue crosshairs. It tidies everything up. So now we start simulation, and you see we got 11 volts. And you're thinking, well, wait a minute. I thought 8 1.5 volt batteries added up to 12 volts. It does. But there's internal resistance in these 8 batteries, because remember, all 8 of these batteries are in series. In other words, they're hooked positive to negative, 8 of them in a row. So they're in series. So the current flow through the circuit has to travel through 8 batteries, then through the light bulb, and back to the beginning of the 8 batteries. And the way I can demonstrate this voltage, I would have to take the voltmeter off of the light bulb and put it directly on the batteries. I'm going to do that. So I'm going to stop the simulation. I'm going to grab this. I'm going to bring it down to here. I think it's attached. And then I'm going to bring this one, whoops, got the wrong part. I'll bring this one over here. Then over there. And I can drag this over that way. I'm just going to delete this. Sometimes I find it, whoops, it deleted just the one point. So I'm going to drag it over here. Doesn't want to go. See what I mean? Sometimes it's easier just to delete the whole wire and start over. I'm not an expert on TinkerCad, folks. Okay. Now I know it's correct. So hit start simulation, 11.1 volts. So this demonstrates that whether I have the meter leads right on the light bulb terminals or on the battery terminals, it's all a conductor between all those points. So let me show you how we can improve this demonstration. So I'm going to stop the simulation. Whoops. See, I hit the scroll button because I meant to be over here scrolling. I wanted a switch. So I want this switch right here. So I'll bring this puppy over, and let me explain to you what this is. You see 3 terminals there, right? Well, pretend like these are 3 little pieces of wire that are not touching each other. And then this slide right here moves a piece of wire from between these 2 to between these 2. So when the switch is in this position, it shorts these 2 wires together. And when it's over here, it switches these 2 wires together. So I'm going to take, I think I learned that if I click that in and hit delete, oh, deleted the whole thing. I'm still learning how to delete individual points. So we'll click and come down here, over here, up to here, then here, down to here, and straight down to here. Now I didn't want these wires red, so that one's picked, I think it's 4. Nope, 5. So if you pick the wire and hit 5, it turns it back green. So now let me start the simulation. Okay? Now watch the voltage when I turn the light bulb off. So this takes the light bulb completely out of the circuit. So when I put the batteries under load, the voltage drops to 11.1. The other 9/10 of a volt is lost because remember, voltage is pressure, and it takes almost a whole volt of pressure to overcome the internal resistance of these 8 batteries in series. So almost a whole volt is lost across the batteries in order to get the current flow out to this meter. And let's say, well, how much current is it? Well, let's stop the simulation, move this puppy over. Notice what I'm doing to tidy it up. So I move it over until I see 2 blue lines, and that tells me that it's square. You don't have to do this. It's good practice, though, if you like your drawings to be neat. Now I need to open up this circuit right here and put in a meter. So I'm going to delete this wire. I'll move the switch over, and I'll move this over. Like that. Now I'm going to get a meter. Now, I could go down here and grab another multimeter, but instead, I'm going to go here and click on this one and do Control C, then go over here, click there, and Control V. Then I'm going to drop it in where I want it. I'm going to squeeze it in, well, about right here, right kind of even with the terminals on these other 2 devices. Now to go up here and say I want amperage. I want current measurement instead of voltage measurement. So pressure you measure across something, across a resistance, across an opposition, across a source. But flow, the measuring device has to be inserted into the flow. All the flow has to pass through it. So I'm going to take the positive lead, and if we do this backwards, it'll still work, and I'll show you in a minute. So I'm going to connect this up. Now, if I want these meter leads to look realistic, then I just hit 1 for that one and 2 for that one. So these are the red and the black meter leads. Now, let's turn on the simulation. So now you see you got 231 milliamps. That's 231 thousandths of an amp. That's 0.231 amps. Okay, if I turn this off, say I got 12 volts. Turn it on, I've got 2.31 milliamps. That's how much current that load is drawing at 11.1 volts. Because the voltage across the light bulb is only 11.1 volts. And that 11.1 volts across that light bulb, remember that inside that light bulb it's incandescent. It has a tungsten filament. It's a high resistance wire, and it opposes electrical flow. It's not a super high resistance. I believe it's about 50 ohms, 48 to 50 ohms of resistance. But that much resistance causes that 11.1 volts pressure across that filament. So the voltage is actually, if we could get inside that light bulb, it's from right there to right there, 11.1 volts. That's how many volts it's taking to force 231 milliamps through that little piece of tungsten wire. And the work done to do that goes from electrical energy to heat energy, heat and light. Incandescent light bulbs produce almost as much heat as they do light. That's why they're terribly inefficient for light, but they also produce heat. So as this heats up, it actually decreases in resistance. So if we could put a time lapse on this, which we can't, you would see that when we first turn the switch on, the current would be a little lower, and then it would increase until it levels out at 231 milliamps. And the voltage across would start at 12 and then drop to 11.1 as the current increases. Now this happens instantaneous to our way of thinking. Okay, I think that's a good enough introduction to TinkerCAD. And notice up here it says all changes saved. You don't have to save it, but remember you have to be online to use this. You can't use this offline. Now you see this name over here? Spectacular Turing. Now you probably don't know what Turing is, but Alan Turing, A-L-A-N, Turing, invented the machine that broke the Enigma code in World War II that the Nazis were using, and he built the first, I don't want to say the first computer because there were people who came before him that developed some computing devices, but he's more or less credited. And you can go on to my website at YouTube channel, PLC Professor on YouTube channel, and you can go to history and you can find videos on Alan Turing and the Enigma. Very interesting. Okay, just one more little thing we could do here. I'm going to stop the simulation. I'm going to move this over until it's a little more tidied up. We'll bring this over until we get the crosshairs. We could do the same thing here, but there would be a conflict between the black and the green wire as far as vision line. I really don't like the looks of this. So I'm going to drag this over here and drag this here. We really don't need two nodes there. So with that one selected, I'm going to hit delete and see what happens. Okay, good. See, I had that one node selected, I hit delete and it went away. So that's a little tidier. If I wanted to make this really neat, I would delete this conductor, then I would go back in and select, go up just a little, come over, and go down. Now I don't want that wire red, so I would hit 5 and it turns it to green. Green wires, if you like, they are the primary circuit. Now the one thing that I'm not real excited about is I made these black and red notes that I can drag this down so it looks more even with this red wire. Looks a little neater. That this meter and these two wires are part of the circuit. If you take the meter out, this circuit won't work. Because remember, as you turn this on and off, okay, right now this little piece of conductor inside of here is between this terminal and that terminal. So there's air right here. Between that green wire and that red wire, there is air. There's no conduction. When I slide that over, then it goes over and it shorts these two pins together, makes a complete path for current flow. So we've got electrons now leaving the negative terminal of this battery bank, going into the light bulb, coming out, going in the black terminal of the amp meter, coming out, going through the switch, and going back to the positive side of this bank of batteries. And so it goes in, goes through all 4 batteries, comes out this wire, the negative lead, and over into the positive on this one, and through all 4 of these batteries, and out the negative terminal and back to the light bulb. These two conductors right here, they are not part of the circuit, but they do have a tiny, tiny current flowing. Because in order for this meter to measure the voltage between that spot and this spot, it has to, it's like a parasitic instrument, meaning that it's parasitic and that it uses a little bit of current in the area of microamps, millionths of an amp, that flows through it, and it uses that little bit of current to determine how much voltage that the meter is put across. So that's a pretty good introduction. I'm going to leave it there, and this is your introduction to TinkerCAD. Now, besides using the wires, there's one other thing you could have used. So I'm going to put the mouse here, and I'm going to scroll back towards me. Well, we'll do it over this way. I can drag the whole thing over here. That's what I'll do. And then I'm going to bring in a breadboard. Okay? I could have wired this whole thing up with a breadboard. let me explain to you what a breadboard is. You see here where it says minus and plus? If I mouse over one of those holes, this is a plastic board, and embedded inside of it, it has conductors. So if you push something down in that hole, it makes contact with a wire that connects all of these holes together all the way across. And that's it. If you go here, all of those are hooked together. If you go here, those 5 are connected vertically. These 5 are connected vertically. So typically what people do is if they're going to use a breadboard like this, they will drag it to where we have a little bit more space, and we'll scroll out and move it over. Whoops, I was going to move it and I clicked on a hole instead of the block, see? So now I'm going to go down and grab a 9-volt battery, because this is typically what you're going to do. I'm going to drop it over here, and I could, see that's minus on the top, plus on the bottom. So I could go right there and drop it, and now it's connected. Okay, so I've got the minus side of this battery connected to all of those, and the plus side connected to all of those. And let's say I want to extend it down here. I simply, 2 ways I could do it. Since I already started attaching the battery right to the breadboard, I'll just go here and go out with a conductor, go down here, tidy that up, make sure this one's tidy, because you're going to be looking at this for a long time. Okay, since I've got it picked already, it's highlighted, I hit 1 to make it black. Okay, now I'm going to go here and do the same thing. And since I've got it picked, I hit 2. Then I'll tidy this up so it's square. That one's square. Okay, so now you see what I did. I extended these, however many, I think like 30 holes, to the 30 holes down on the bottom, also marked minus in black. Now, it doesn't automatically show you that these 30 are hooked to these 30. You see what I'm saying? Because this is the characteristic of this board. All 30 of these holes are a socket that are in series. So all 30 of these, all 30 of these, all 30 of these, all 30 of these. And the little green pop-up shows you that. And these show you how these are connected together. Now you could do the same thing if you wanted to connect one of these 5 to one of these 5. Now I have no reason for doing that, but just for grins, I'll click here, go over here, go down here, and click there. Now, that's not a minus or plus bus for voltage for the system. So I could make it a green wire, like the other green wires. I can make it almost any color I want. Black, red, orange, yellow, green, blue, light blue, darker blue, cyan, whatever you want to call that in cyan. I guess you might call that some kind of violet or something. In each of these colors, you select the wire so it looks like that, then you hit 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know what 0 will do, I'll hit it. Oh, hey, got another color. How about that? So it's 0 through 9. I should have known that. Okay, so you can change these colors to identify different sections of your circuit as you're building it, just as I did over there with the light bulb and the meters. Okay, that's enough for right now, because we are at 33 minutes. Wow. That took a lot longer than I thought it would. Probably because I tried to throw in some knowledge of circuits along with what I was doing. I couldn't help myself. Okay, and I've not spent a lot of time working with TinkerCad, but I've got thousands of hours. I mean, tens of thousands of hours with electronics, with electricity. I started with vacuum tubes. As a matter of fact, transistors were just becoming commercial when I was a kid, and I did a science fair project back in the 50s, 1950s, where I took a vacuum tube, a photocell, a photoelectric cell, little glass tube about this tall, and I took a record player, okay? I disconnected the speaker wires and I hooked them up to a flashlight bulb inside of the reflector. So I took the flashlight apart and hooked the speaker wires up to the light. And then when it played music, the light would flash, okay? And then I had a long black box, 4 foot long, and at the other end of that box I had a photocell, and then I had the 2 wires from that. Well, it probably had a filament, I don't remember. But anyway, I had the 2 wires from that going to an amplifier and a speaker. And as the music played, the light modulated, the photocell picked it up, amplified it, and you heard the music coming out of the speaker with no electrical connection between the 2 devices. And if you stuck your hand in there and blocked the light, the music stopped. Okay, now, back when I was a kid, that was pretty cool. I do actually have some odd memories about science fairs. There was one science fair where I built a crystal radio, where I actually hand wired the coil, handmade everything, and it worked beautiful. And in the science fair, there was another kid that bought a plastic kit from, I don't know, some company, maybe Heath Kit, who knows. And all you did was just put it together. You didn't really do anything other than you assembled it. And he got first prize. And at that time I'm thinking, well, wait a minute, mine works just as good as his. Mine's all homemade. You know what? I decided I learned much more than he did by building the whole thing myself. I didn't say nothing, but that was a lesson learned early in life about the value of doing the work yourself simply to learn. One thing I want to leave you with today is it's not about who gets first prize. It's not about who gets the accolades and all the credit. It's what you walk away with that's permanent, your permanent experience. And I love building that crystal radio. I was fascinated with it. You got to build one, even though who needs one, right? I mean, you can buy a little iPod probably for $20 and a little earbud that you can tune into AM radio. I mean, I don't have one. I don't need one. So there's no commercial value in it, but there is education value. You owe it to yourself, if you're really interested in electricity and electronics, to go find the plans to build a crystal radio. And if you're really ambitious, instead of buying a diode rectifier, you can get a gallium crystal and what's called a cat's whisker. And it's a little piece of fine wire that touches the gallium crystal and it forms a rectifier, literally. And it works great. So all education is good and hands-on is even better. So thank you for watching. And I hope you watch this before you watch any of the other episodes that I use TinkerCAD, because that'll make them make more sense. Thank you.